Good afternoon, ladies and gentlemen. Welcome to yet another exciting episode of Dave Does Math from Home. Today we are talking about section 8.1. We are doing systems of linear equations, which are like linear equations. They have x's with no exponents on them. They have constants. Nothing is squared, cubed, no square roots, no weird stuff. They're first order polynomial, but they're a little different. We're going a bit beyond what we did in section 1.2a when we were just solving regular linear equations. And the big difference is these guys. The linear equations we're going to work with in this section have two variables. This is linear on x and it's linear in y at the same time. There's two of them now. This is going to be something of a problem for us because we can take this thing and solve it for x. Solving this thing for x would mean adding 3y to both sides. And then you'd have 2x equals -9 plus 3y. And then you could divide everything by 2 and you would get x equals -9 plus 3y over 2. Like this is solved for x. X is by itself. It's isolated. It's solved. The problem is we still have an expression here with variables in it. So solving this thing for x does not give us a concrete usable number here. And so we could solve it for y as well. We would just subtract the 2x from both sides and then divide by the -3. We can do that. We still have the same problem. Solving this thing for x still has a variable. Solving it for y still has a variable. Which is where the idea of systems comes in. The way we're going to solve this problem of still having variables is we're going to do two of these things at once. So let's say we know that 2x minus 3y is -9, but also let's say that at the same time we know that 5x plus y is 20. Now I still have two variables here, but now I have two pieces of information about my two variables, and this is a system of linear equations, and this is something that I can solve. I can figure out exactly what y and x are in this system of equations. There are two basic techniques that we're going to use to solve these systems of equations. One of them is called substitution, and the other one is called elimination. And I will show both of those for this first problem. Some systems make elimination much easier. Some systems make substitution much easier. So it's kind of like a case-by-case basis. It's good to become relatively practiced with both techniques so that you can use them on the appropriate problems. I'm going to start with substitution because it's probably the easier one to be introduced to. The substitution technique means you pick one of these four variables that looks like it'll be really easy to isolate. And mostly when I say easy to isolate, I mean no fractions involved. Like you just saw my attempt to isolate this x. Isolating this x was adding 3y to both sides and dividing by 2. That gave me -9/2 and +3/2 y. There were fractions everywhere. That doesn't count as easy to isolate. If I isolate on this variable though, this second y, there won't be any fractions. In fact, I can do that just by subtracting 5x from both sides here. Minus 5x minus 5x. Now I have y equals 20 minus 5x. This only took one step to isolate. It's pretty effortless to do that. Now that this y is by itself, I can substitute it into the other equation. You have to be careful when you do this. One of the common mistakes students make when substituting is they'll use an equation to isolate a variable, and then they'll plug that variable back into the same equation, and that won't help you. That will create this weird loop where once you simplify things here, you're going to get like 0 equals 0 or like 20 equals 20. And you'll be like, yes, I knew that. That's not helpful. So whatever equation you use to isolate a variable, you have to plug that variable into the other equation. So if I plug this variable into the top equation, I will get 2x minus 3 times 20 minus 5x equals negative 9. And this is an extremely helpful improvement for us because it has one variable. And we know how to solve things that have one variable. We've been doing that for weeks now. This is just a linear equation of just x's. We distribute, we combine like terms, we isolate things. 2x minus 60 plus 15x equals negative 9. So I'll add 60 to both sides. I'll combine these like terms here. This is 17x equals 51, and that'll give us x equals 3. Here's the other thing you have to be really careful about. It's very tempting to get to something like this, x equals 3, and then put a box on it and walk away. But we're not finished. We started with 2 equations of 2 variables, and we're not finished until we have 2 solutions for those variables. So we know what x is, but we don't know what y is yet, so we need to keep going. The good news is we have 2 different equations we can plug our x value into to get y. And that means you should use both. You can plug your x into, let's plug our x into this bottom one. 5 times 3 plus y equals 20. Again, we have a pretty effortless linear equation here. This is 15, so you subtract 15 from both sides. You get y equals 5. That's the answer you get using just the bottom one. When I said you should plug your answer into both, what I meant is with these kinds of problems, it is very, very easy to check your answer. We have both of these solutions. We have an equation that we haven't used yet. Like if we plug this back into the bottom equation, it's obviously going to work because this thing came from the bottom equation. We can plug these into the top equation to check our answer very easily. 2 times 3 is 6 minus 15 equals negative 9. So yeah, that works. This answer checks out and we are all set. I want to make a big deal out of checking your answer in these problems because it's so easy. On most tests and quizzes, if you get something wrong and you don't check your answer, I'll take off a point or 2 depending on how wrong you get it, because making small mistakes is really understandable and I am not about punishing people for that. If you make a small mistake on one of these problems and then you don't check your answer, I'm going to take off a lot of points because checking your answer is really easy and I expect you to do it. So that is the substitution technique. You solve for one of the variables, you plug it back into the other equation to create a linear equation of only one variable. You solve that, you take that solution to find your other variable. Solution technique, or substitution technique. I'm going to keep going with this problem. I want to talk about I'm going to erase all of this substitution technique stuff, go back to the original problem, and then show you what the other technique looks like, elimination. So the elimination technique is based off the idea that we can do anything we want to these equations, and that includes adding them together. Adding them together is definitely an option. A lot of the times, adding them together is not going to be a very exciting option. Like, if we add these things together right now, we'll get 7x minus 2y equals 11, which kind of just looks like a third row of information for us that's not helpful. Adding these two equations together becomes really helpful when it eliminates one of these variables. Right now, that's not going to happen, but imagine if we multiplied this entire equation by 3. Then it becomes 15x plus 3y equals 60. And this one, I'm going to leave alone. I'm not going to change it at all. It's going to stay 2x minus 3y equals negative 9. Now, if we add these two equations together, this becomes 17x. This zeroes out. It's eliminated. Which is why this is called the elimination technique. And this is just 51, which hopefully looks really familiar. 17x equals 51. That's how we got x equals 3 in the last one. Is that even visible? Oh, that stupid glare. Here we go. Where do I need to stand? There. I'll stand here. I'll block the glare. Okay. So, the good news about the substitution technique and the elimination technique is they're only really distinct in terms of how you start the problem. Like, they will give you two different options for solving for the first variable. Once you have this variable settled and done and solved for, the rest goes the same. So, like, plugging x equals 3 back into this to solve for y, to give us a y value, and then checking it in the other equation, that works exactly the same as what we just did in the substitution technique. So I'm not going to do that again. So yeah, elimination technique, you can multiply these equations by whatever you want to set up a situation where adding these two things together will zero something out. We could have also done, you could have also eliminated on the x in this case. If you multiplied this by 5 and this by negative 2, then this would be 10x and this would be negative 10x, and they would zero out, and you could eliminate on x. And yeah, no matter what you do, elimination or substitution, you can solve for one variable first, you plug it back into another equation, you solve for the other variable, you plug both of them into the other equation to check your answer. That is systems of linear equations. I have some more examples that I want to go through, but I'm going to put those in a separate video. So we're going to end this one here for now.